Welcome back to another edition of TEC Tube. I'm your host, Ryan Hoger. Today we're going to go through refrigerant leak detection systems for A2L refrigerants, specifically R454B. So we have a dissipation control board here today. We got a leak sensor. We're going to show you how they work, what the basic functionality is, and what some of the alert codes you might see on them could be. So these leak detection sensors are factory installed in the evaporator coil section of rooftops, air handlers, and in this case, a split system, a small tonnage split system. These sensors, the ones we're utilizing here, have 4 wires on them. They are going to connect up to a dissipation control board, which we'll go through here in a second. And the purpose of that control board is if there's a leak in the evaporator coil section, it's to A, turn on the main blower to move the airflow through the cabinet so we don't have all the refrigerant pooling in one spot during a leak. B, turn off the compressor so we don't continue to try to circulate refrigerant around the system. And C, shut off any additional sources of heat like a gas furnace or an electric heater or something like that so we don't accidentally have a potential ignition source available to us. On this control enclosure, we'll be utilizing these with furnaces. If you have a fan coil or a rooftop or other type of system, it's very likely that you won't have this exact enclosure, but you'll still have the same circuit board physically inside the unit that's mounted in there. So the wiring for these, if you have a package system, you don't have to worry about it. Fan coils and rooftops, factory wired, ready to go. Split systems like air handlers, or in our case, residential split today, we do have to field wire these. And there's a bunch of wires on here. The nice thing is they're all individually labeled. For example, this one says common to furnace C, Y out to outdoor unit. They're each labeled. What's essentially going to happen is that all the wires coming from your thermostat are going to get intercepted by this control board. And instead of letting Y and G and W pass straight through to the HVAC equipment, this controller is going to get first dibs on whether it allows them to pass through or not. And if there's no problem, i.e. no leak detection, they just pass straight through. Y and W go straight through. If there is a problem, it'll block Y, it'll block W, and it'll force G on if there wasn't already a fan signal in order to enable that fan blower to run. So that's kind of on the wiring side of the equation. You can check out these wiring diagrams to kind of give you a little more detail on that. The actual circuit board itself does have 4 different wiring connections on it, most of which you'll be using, with some you will not. So for starters, there's 4 pins down on the bottom here. That's where this leak sensor is going to actually wire to. It's a 4-pin harness. It's going to plug right into there. So that one's pretty straightforward. The other one up on top here, the 8-pin harness, that's all these wires that I was just telling you about here. Some of them are ins from the thermostat and some of them are outs back to the equipment. The other 2 that you're not going to use very often, up top here, you have some miscellaneous contact outputs, a normally open and a normally closed one. You're probably not going to use them, but if somebody wanted to wire it over to a BAS system or something like that, this is how you would utilize that. And then the bottom one over here, this green block, you'd have one of those Phoenix style connectors on there with an ABCD terminal on it to go to a communicating piece of equipment, should you have that type of equipment, residentially speaking. These leak detection sensors will come factory installed in the evaporator coil section of, in this case, a split system. Same thing would happen on a package system like an air handler, fan coil, rooftop unit. The UL requirement is that they trigger at 25% of the lower flammability limit of that particular refrigerant. This particular sensor I have in my hand happens to trigger at 20%, which is better than the UL standard, so that's fine. There's a 4-wire pin on here that's going to connect into the dissipation control board. That dissipation control board is going to look like this. If you have a fan coil or a rooftop, you'll probably just have the board. But if you have a split system like I happen to have today, then it comes in this plastic enclosure so it can be mounted on the side of the return duct or something like that, or on the wall perhaps. That enclosure obviously opens up. We have all of our wiring terminals in there. The first one we're going to look at is this 8-pin harness on the bottom. That 8-pin harness has all these wires in here, which is obviously a little intimidating. They're all labeled, which is nice. And obviously there's a wiring diagram that tells you what they're all for. It's a little scarier than it actually is. So for example, the labeling, W in to T stat W, Y in to furnace Y. So what essentially this job is of this board to do is intercept all the thermostat signals. All the signals coming from the thermostat get intercepted by this board, and this board then decides if they get relayed out to the equipment. So you got 3 or 4 things coming in, 3 or 4 things coming out. So when there's a leak detected, it'll A, shut off the compressor, so it'll block the Y signal. B, it'll turn off any auxiliary heat that you have, meaning electric resistance heat or a gas furnace, so it'll block the W signal. And C, it'll force the blower on, so it'll energize G, even if the thermostat wasn't asking for G at that particular moment. There is one button on here. That button is used for a couple different things. If you just press it one time, one normal press, it'll initiate a test mode. So instead of trying to leak refrigerant onto the sensor and test everything that way, which would be obviously very wasteful, where you push the button and you can see that everything is working electrically. Everything that's supposed to shut off, shuts off. Everything that's supposed to turn on, like the blower, turns on. Additionally, you can hold this button for 5 seconds or more, and in that case, it'll recall the last fault code so you can see what happened prior to you being there troubleshooting the problem. And then lastly, you can press the button multiple times to clear out old fault codes. There's also 2 small indicator lights on there next to the button. One is a communication light to let you know everything's communicating correctly, and the other one is a fault indicator light, an alert light. So if there's a problem, it'll flash. For example, if it flashes one time, flash, off, that's telling you that there's a leak being detected at the current time, and it's in the dissipation mode, which means fan on, heating and cooling off. If it flashes 3 times, so flash, 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 and then pauses and then flashes 3 times again and continues on, that tells you the leak is no longer happening. No leak is currently being detected, but we had one in the past 10 minutes and it's finishing out the dissipation cycle. So after the leak is over, it still keeps the heating and cooling off for 10 minutes and it runs the fan for that same 10 minutes. And then there's a few other less common alerts you can count the lights on to see what you happen to have in those cases. Thanks for joining us today. And as a reminder, this 2-part video series was just to give you an idea of what's going on. You should definitely attend a more in-depth class, either an in-person one or an online one for 2 or 3 hours so you get the full scope of everything that you have to do with these new refrigerants. In general, it's not hard. There's just a few more rules and a few more things you got to pay attention to. We'll see you on the next video.